Have you ever stopped to think about how much pasta the world really eats? Picture this. Nearly 17 million tons of pasta rolled off production lines across the globe in 2022 alone, according to the International Pasta Organization. That's enough noodles to stretch across continents in endless golden ribbons. And here in the United States, we consume almost 6 billion pounds of pasta every single year, making it one of the most beloved comfort foods in American households. Whether it's a steaming plate of spaghetti and meatballs, a creamy bowl of fettuccine alfredo, or a quick mac and cheese on a busy weeknight, pasta is deeply woven into our diets and traditions. But behind every forkful of noodles lies a fascinating story of agriculture, science, and engineering. What hidden machinery and precise steps transform a handful of grain into the spaghetti twirling on your plate tonight? The answer takes us on a journey that spans thousands of years and bridges cultures, technology, and taste. Pasta's history is older than many civilizations, and yet it still feels like a modern-day staple. Some of the earliest evidence suggests that the Chinese were stretching and pulling noodles as far back as 2000 BCE. Centuries later, Arab traders carried dried dough across the Mediterranean, introducing the idea of preserving wheat in a form that could last for months. By the 13th century, pasta had firmly rooted itself in Sicily, where the sunny climate made it perfect for drying wheat-based foods. As it spread throughout Italy, pasta became more than just a practical storage solution. It became a symbol of regional culture. Different towns invented their own shapes and sauces, each one reflecting local ingredients and preferences. By the Renaissance, pasta wasn't just food for the poor, it was a common thread uniting rich and poor alike. Industrialization in the 19th century forever changed the scale of pasta making. Mechanized presses and new drying methods allowed pasta to be mass-produced and shipped across borders. When Italian immigrants carried their traditions to the United States, pasta quickly found a home in American kitchens. It went from immigrant comfort food to a nationwide favorite, loved by families, restaurants, and eventually adopted into every corner of U.S. food culture. Today, pasta stands as one of the most consumed foods worldwide, connecting ancient tradition with modern industry in every bite. The story of pasta begins not in the factory but in golden fields of durum wheat. Unlike common bread wheat, durum has a unique strength. It is hard, dense, and packed with protein, giving pasta its firm texture and ability to hold shape. Farmers harvest the crop in late summer, collecting kernels that shine in the sun like tiny beads of amber. Once cut, the wheat heads are sent to towering mills where the transformation begins. Inside, high-speed air separators blast away dust, husks, and small stones. What remains is pure wheat kernel, which then meets giant steel rollers that crush and grind the grains into semolina. This coarse, yellow flour is unlike the fine white flour used for bread. It has a granular feel, almost like tiny crystals, and it's precisely this texture that makes pasta unique. Every particle is carefully graded so that mixing later will be smooth and consistent. In fact, moisture content is measured constantly. An extra 1% can ruin the dough's texture. Automated sensors check samples every few minutes, and operators watch live readings on computer screens. When the semolina is ready, it's stored in silos as the raw foundation of pasta. Now comes the stage where flour becomes dough. Inside massive stainless steel hoppers, semolina meets purified water in carefully measured ratios. Roughly 100 kilograms of semolina requires about 30 liters of water, a formula tested and perfected over decades. Paddle mixers slowly churn the blend, but unlike bread dough, the goal here is not smooth elasticity. Instead, the semolina and water are folded into a sandy, crumbly mix that looks almost unfinished. This rough texture is key. It allows the extrusion machines that come next to compress the particles tightly, creating pasta that has the perfect bite. Temperature matters too. Warm water encourages gluten bonds to form quickly, while colder water slows the process down, allowing more control over texture. Depending on the pasta style, whether it's long strands of spaghetti or delicate shells, technicians tweak these conditions to achieve elasticity and durability. By the end of this stage, the dough isn't a neat ball but more like moist crumbs, crumbly yet sticky enough to hold together under pressure. Cameras and scanners check for uniform color to ensure no part is too dry or too wet. Once cleared, the dough is ready for its most dramatic transformation. Extrusion is where the magic happens. Imagine tons of crumbly dough fragments being forced at high pressure through intricately designed metal plates called dies. These dies, sometimes made of bronze, sometimes of Teflon, determine the final shape of the pasta. Hydraulic screws push the dough against the patterns, and out comes spaghetti, penne, fusilli, or farfalle, each with razor-sharp precision. Bronze dies leave the pasta surface slightly rough, which is perfect for holding on to sauces like marinara or Alfredo. Teflon dies, on the other hand, creates smooth, glossy pasta that cooks faster and is often favored for commercial markets. High-speed knives attached to the dies slice tubular shapes into exact lengths, and rotary blades cut elbows or small shells, producing thousands of identical pieces every minute. The process is so fast and rhythmic it feels almost alive. A single extrusion line can churn out over 6,000 pounds of pasta in just 1 hour. Imagine the chaos if a machine broke down mid-run. The thought of thousands of meals wasted in minutes is enough to make anyone cringe. But freshly extruded pasta is fragile. It's loaded with nearly 30% moisture, far too much for long-term storage. Without intervention, it would spoil within days. That's where industrial drying tunnels come in. Conveyor belts carry the pasta into enormous chambers where hot, dry air circulates continuously. The temperature hovers above 120 degrees Fahrenheit, carefully controlled to avoid disaster. Too much heat and the pasta will crack, snapping into unusable fragments. Too little heat and bacteria can thrive, making the product unsafe. The drying process takes anywhere from 8 to 12 hours, depending on the pasta's thickness and shape. Long spaghetti strands often hang vertically, swaying slightly as air passes over them, while shorter shapes like macaroni tumble gently on mesh trays. Sophisticated sensors monitor humidity levels with remarkable precision, maintaining conditions within a 1% tolerance. After drying, the pasta moves into tempering rooms where it cools gradually. This slow shift prevents fractures caused by sudden temperature drops. Workers snap test strands, examining the interior color and structure to confirm that the golden hue is consistent all the way through. Only perfectly dried pasta continues to the next stage. Now the pasta is shelf-stable, meaning it can survive months or even years in packaging without spoiling. From here, the focus shifts from preserving to presenting. Conveyor belts guide the pasta into automated scales that weigh each portion with pinpoint accuracy. A bag of spaghetti must contain exactly 454 grams, no more and no less. Machines funnel the pasta into bags or boxes, vacuum sealing them to remove air and lock in freshness. Many packages include a clear window so shoppers can admire the golden strands inside, a marketing touch as much as a practical one. Labels are printed and scanned to ensure cooking times, nutritional information and batch codes are all correct. Anything with a misprint is automatically discarded before it reaches the next stage. Finally, robotic palletizers stack hundreds of boxes onto wooden pallets, and forklifts load them into trucks or shipping containers. Within days, that pasta could be sitting on a supermarket shelf in Chicago, Los Angeles, or even across the ocean in Tokyo. Every step is monitored, measured, and logged, ensuring that every plate of pasta tastes just as good as the last. The journey of pasta from field to fork is astonishing, but the scale becomes even more impressive when you look at how global chains handle pizza. Take Pizza Hut, for example, a brand so ingrained in American food culture that almost everyone has a memory tied to it. Every year, Pizza Hut sells more than 300 million pizzas worldwide. In the US alone, the CDC reports that nearly 1 in 8 Americans eats pizza on any given day. Think about that. On any random Tuesday, millions of ovens are blazing, cheese is melting by the ton, and dough is being stretched in quantities so massive it's hard to imagine. And yet, every pizza that lands on your doorstep is nearly identical, whether you're in Texas, Tokyo, or Toronto. Behind that familiar red logo is a finely tuned system engineered with military-like precision. Pizza Hut's story began in 1958 when two college brothers, Dan and Frank Carney, borrowed $600 from their mother to open a small pizzeria in Wichita, Kansas. Their goal was simple: bring the Italian-American favorite into a casual, family-friendly setting. The idea caught fire immediately, and within a year, franchising began. By the 1970s, Pizza Hut had become the largest pizza chain in the U.S., and its iconic red roof restaurants dotted suburban landscapes. But making pizza on this scale requires a level of organization most of us never think about. Dough, for example, can be made fresh in some stores or supplied as frozen batches from central facilities. Frozen dough requires over 20 hours of careful thawing before it's ready, while fresh dough takes about 4 hours to proof. In both cases, massive mixers handle hundreds of pounds at a time, portioning the dough into balls marked with batch codes for quality control. This ensures the same fluffy crust whether you're biting into a slice in Kansas or sharing a pan pizza in Tokyo. From there, toppings, sauce, and cheese flow into the process with equal precision, proving that even something as casual as a Friday night pizza delivery is backed by incredible science and logistics. Have you ever wondered how the foods we love, like pizza and hot dogs, are made on such a massive scale that every bite tastes the same no matter where you order it? From the cheesy pull of a Pizza Hut slice to the smoky snap of an all-American hot dog at a ball game, there's a hidden world of precision, science, and machinery working behind the scenes to make it all possible. Today we're diving deep into the secrets of food factories, where recipes are engineered for consistency and millions of meals are prepared every day to meet America's endless appetite. By the time you finish this journey, you'll never look at your favorite pizza or hot dog the same way again. Consistency in food manufacturing is everything. Even the smallest mistake, like yeast not activating properly, can ruin entire racks of dough. That's why dough production is treated less like cooking and more like science, where fermentation speed, storage needs, and timing must be balanced with incredible accuracy. Once the dough is mixed and divided, it's shaped into perfect balls and sent into proofing rooms. Here, temperature and humidity are tightly controlled, because yeast is sensitive. Even the slightest change can alter its activity. Proofing gives dough its signature lift, allowing carbon dioxide to expand the structure, which creates the light, airy texture that customers expect from a fresh pizza crust. In fresh dough systems, trays of proof dough are moved into storage coolers where refrigeration slows down yeast activity. This pause in fermentation holds the dough stable for hours, giving workers flexibility while maintaining quality. For frozen dough, the process works in reverse. Instead of proofing before storage, frozen dough is thawed later to mimic that same soft, risen texture. These different methods all lead to the same goal: dough that's easy to handle, flexible enough for shaping, and ready for sauce and toppings. Once the crusts are prepared, it's time for the flavor base that defines every pizza: the sauce. At Pizza Hut, giant steel kettles cook dozens of gallons of concentrated tomato paste blended with carefully measured spices. The process preserves both acidity and natural sweetness, creating that bold flavor profile recognized worldwide. Once cooled, the sauce is pumped into automated portioning machines that spread an even layer across every crust, ensuring no pizza leaves the line with too little or too much sauce. While tomato remains the classic base, customer favorites like creamy white sauce and tangy barbecue give pizza lovers plenty of choices. If you could only pick one sauce for the rest of your life, would you stick with traditional tomato or go bold with something different? Cheese production in these factories is equally fascinating. Massive blocks of mozzarella arrive at the facility, where high-speed shredders turn them into thousands of fine strands every minute. These shreds are designed to melt predictably under heat, creating the gooey stretch Pizza Hut is famous for in its commercials. Toppings like pepperoni, sausage, mushrooms, and peppers are also processed in bulk. Industrial slicers and portioning machines ensure uniformity, because every extra or missing slice of pepperoni multiplied across thousands of pizzas can mean serious costs for the company. Assembly is a fast and highly choreographed process. Crusts are flattened, sauced, topped, and lined up on conveyors. Workers keep an eye out for imperfections, but machines handle most of the heavy lifting. The next stop is the oven, where standardization guarantees that no matter where you are, whether you're eating a pan pizza in Ohio or grabbing a slice in Manila, you get the same flavor and texture. Conveyor ovens bake at around 475 degrees Fahrenheit, with timers and airflow engineered to produce golden crusts and perfectly melted cheese every time. Even when Pizza Hut reformulates recipes like the legendary pan pizza, new versions are tested for years to make sure they bake properly in these ovens. Once baking is complete, pizzas move to boxing stations. Boxes are more than just branding, they're engineered to control steam and moisture. Too much trapped heat can soften the crust, so venting holes allow the right amount of steam to escape, preserving crispness until the pizza reaches your home. Each box also carries a traceable code that links back to the specific dough batch and sauce lot, ensuring any issue can be tracked in seconds. For frozen retail pizzas, the process includes cooling tunnels, vacuum sealing, and stacking for distribution. For restaurants, fresh pizzas are boxed and sent out within minutes, ready for delivery drivers to rush them to waiting customers. From dough to oven to doorstep, every step is built on speed, reliability, and consistency. But pizza is only one piece of America's food obsession. Every summer, the United States consumes over 7 billion hot dogs, according to the National Hot Dog and Sausage Council. That breaks down to about 818 hot dogs eaten every single second during peak grilling season. From baseball stadiums to backyard barbecues, the hot dog has become an American icon. But behind the smoky flavor and perfect snap lies an industrial process that turns simple meat into uniform franks by the thousands. The story of the hot dog begins in Europe, where sausages have been part of food culture for centuries. German immigrants brought frankfurters and wieners to the United States in the 19th century, selling them from pushcarts on busy city streets. By the late 1800s, they had become a staple in cities like New York and Chicago, celebrated for being cheap, portable, and delicious. The first ballpark hot dogs were served in the early 1900s, forever tying the food to American sports culture. After World War II, demand exploded, and factories adopted assembly line techniques to produce hot dogs on a massive scale. Since then, they've become inseparable from summer cookouts, the 4th of July, and sporting events across the country. Making a hot dog starts with cuts of beef, pork, or poultry selected for the right balance of protein and fat. These cuts arrive at processing plants chilled and are checked for bone fragments using metal detectors. Large grinders reduce the meat into smaller pieces, and the texture becomes finer with each pass. Fat content is carefully measured. Too much fat makes franks greasy while too little leaves them dry. By the end of grinding, the mixture resembles ground hamburger, but it's prepared for an even more precise transformation. The ground meat is transferred to giant mixing bowls, where salt, curing agents, and spices are added. Seasoning blends can include garlic, paprika, mustard seed, and other secret ingredients unique to each brand. High-speed choppers whip the mixture into a smooth paste. During this step, ice chips are added to keep the meat cold and create the proper texture. The result is a silky emulsion, a defining feature that gives hot dogs their uniform bite, unlike traditional sausages that have visible chunks of meat. It's this stage that ensures every hot dog looks, tastes, and feels the same no matter where you buy it. Once the emulsion is ready, it's pumped into cellulose or collagen casings through high-speed stuffing machines. These machines can fill hundreds of feet of casing in minutes, twisting the links into that classic hot dog shape at lightning speed. Long strands of linked hot dogs are draped over racks, moving along conveyors that stretch as far as the eye can see. Workers and automated sensors monitor for uniformity, because even slight variations in size or weight can throw off the cooking process. Imagine watching a machine twist and tie off more than 1,500 hot dogs every minute. It's mesmerizing and a little surreal. The next step is cooking, and this is where the magic happens. Racks of hot dogs enter massive smokehouses or steam ovens, where controlled heat firms the meat while developing flavor and color. Cooking temperatures usually sit between 160 degrees Fahrenheit and 180 degrees Fahrenheit, hot enough to kill bacteria but low enough to preserve the smooth texture. Some factories burn hardwood chips to generate authentic smoke flavor, while others rely on liquid smoke applied directly to the casings. This stage also produces the hot dog's signature reddish-brown color, thanks to natural reactions between curing salts and heat. Precision is critical. Undercooked hot dogs don't pass safety checks, while overcooked ones split open and are discarded. After cooking, the hot dogs are cooled slightly and moved into packaging lines. Automated counters sort them into packs of 6, 8, or 10, depending on brand and market preference. Each group is vacuum sealed in plastic, protecting the franks from contamination and locking in freshness. Labels with nutrition facts, expiration dates, and barcodes are applied, and advanced cameras scan each package to make sure seals are airtight. Boxes of hot dogs are then palletized, loaded into refrigerated trucks, and shipped to supermarkets, stadiums, and restaurants nationwide. Within just a few days, what started as raw meat ends up in your hands, ready to sizzle on a grill or boil in a pot. When you step back and look at the entire system, it's astonishing. From delicate strands of mozzarella covering conveyor-baked pizzas to endless ropes of hot dogs rolling through smokehouses, the foods we think of as simple are the result of extraordinary coordination. Behind every slice of pizza and every frank at a cookout lies a massive industrial operation that balances science, timing, and engineering with almost unbelievable precision. Factories don't just produce food, they create traditions. They engineer family pizza nights, backyard barbecues, and stadium memories. The uniform taste and texture we take for granted are the results of countless details being managed flawlessly. A single mistake in yeast fermentation, oven timing, or casing twist can mean failure, but when everything works in harmony, the result is abundance. So the next time you grab a slice of pizza or bite into a hot dog, remember that you're tasting more than just food. You're experiencing the product of a carefully engineered system designed to make comfort, convenience, and tradition available at scale. And if you're curious to keep uncovering the hidden processes behind the foods you love, make sure to stick around because we're just getting started on this delicious journey.